So for our standard deviation, we would do 2.8 squared plus 2.5 squared, and then square root that. So, why didn't you guys tell me you couldn't see it? 3.75? So spread is 3.75 inches. So then to find the probability that a randomly selected young man is at least 2 inches taller than a randomly selected young woman.
Is the spread usually arranged?
Say that again?
Is the spread usually arranged?
It can be arranged. There's 3 types of spread: range, standard deviation, interquartile range, and I feel like I'm forgetting another one. All right, so B, find the probability that a randomly selected young man is at least 2 inches taller than a randomly selected young woman. So we know the shape of our distribution is normal. What's at the center? 4.8. And then 4.8 minus 3.75, one standard deviation, would put us at 1.05. So 2, it's got to be like right here. This is 2. So we're looking for probability that he's at least 2 inches. So does that mean he can be more than 2 inches taller than the girl, or? Okay, so we're looking at this area. So how do we find that area under the curve? Normal CDF. What's the lower bound? 2. Upper bound?
Big number.
Big number. Mean? Standard deviation? And really, we should label this with 4.8, comma 3.75. So, normal CDF is under second bars. What is it?
Yes, 0.7.
Spoiler alert. The answer is 0.7723. So probability is 77%.
What rounding is that? 7724. If you're going to say it like that. You
I
just thought
offered to
school-
let Tanner teach. Any
Tanner would
questions?
just teach the
Wait,
four prisoner problem. It's only different.
why wouldn't we use the standard deviation by like just adding 2.8 and 2.5 together?
Well, first of all, remember what chapter was it? I want to say it was like chapter 6 when we talked about random variables and binomial variables and geometric variables. You cannot add standard deviations. You have to add their variances. Remember, you had to square it, add it, square root it, which is what I eventually remembered. But I was thinking we had to use the sample size. Okay? Did that answer your question?
Yeah.
Okay. All right, so now we're looking at means. So we've been looking at the difference of proportions. Now we're going to look at the difference of means. So we're going to draw a picture for the sampling distribution of x bar 1 minus x bar 2, which we kind of already talked about in the warm-up. So if x bar 1 is normal, it should say the distribution of x bar 1. And the distribution of x bar 2 is also normal, then we can assume that the distribution of the differences would be normal. So we have our normal curve. And the statistic would be the x bar 1 minus x bar 2. What would we use for the parameter? What is the mu sub 1 minus mu sub 2? And if our statistic is a good measure of the parameter, what is the mean of our statistic? It would be the mu minus mu. So what would be at the center of our distribution? That. Mu 1 minus mu 2.
Whoa, you too?
Okay. Now, even though it's a normal distribution, when you're working with means, we use not z, but t. So we would say that it's a t distribution. And what do we put as the subscript? Degrees of freedom. And then it'd be mu 1 minus mu 2. And then standard deviation, which is a long formula. So I'm going to draw an arrow instead of actually writing it. And the standard deviation, square root of sample standard deviation of 1 squared over n sub 1 plus standard deviation of sample 2 squared divided by sample size. It's weird because you have like a subscript and a superscript. You're squaring your sample standard deviation.
Is that what we just did?
Except for we didn't have sample sizes. But now we will.
And we wrote an N.
These are the kinds of equations we just.
If you don't have the sample size, you would just do it without the sample size. Yeah. Okay?
Are you going to put one without an exercise?
You mean like on the test? I'll have to double check. I don't remember there being one without a sample size, but I'll double check.
These are the kinds of equations you put on a board in your house and people walk in and they're like, oh, this is.
Like Sheldon from Big Bang Theory. Love Sheldon from Big Bang Theory.
This
Except
is
he
a
doesn't
long
know.
packet.
He doesn't really know anything about math.
All right, Mr. Wilcox recently purchased some new Hankook Ventus R compound racing tires. He believes they will improve his track times. Mr. Wilcox knows that his, thank you, old tires, Skylar, gave him an average lap time of 96 seconds for an SRS of 38 laps with standard deviation 3.5 seconds. When he goes out to the track again with the new tires, he gets an average lap time of 94 seconds for an SRS of 40 laps with a standard deviation of 2.5 seconds. Construct and interpret a 95% confidence interval for the difference of means.
In not much space? Or not little space?
How about
We skip state.
And plan,
and just do it.
What do you need to
What do you
plan?
need to, here, we'll just kind of abbreviate. State, what should you state in your state part?
The first
A sentence
The
of what
true
you want to
difference.
estimate. We want to estimate the true difference
of speeds.
of average lap time. We want to estimate
to a 90.
true difference of average lap time.
To a 95% confidence.
If you have to say which one is
mu1,
mu1.
uh-huh.
That's so good.
So,
Mu1 is
we're good.
average old.
Yeah.
Average of old.
Mu1 will be the old
Mu2.
average of old. Mu2 average of new. And then,
What else do we have to say? Is that it? No.
well, let's write down what we know. You don't have to necessarily put it into the state part of your problem, but you do want to write down what you know. So we know X bar 1 is old tires average 96. The standard deviation S sub 1 is 3.5. Then we have our new tires, have an average of 94. And then a standard deviation of 2.5. Right?
Is that 96S?
Yeah, seconds. I labeled the first one and then I got lazy. And then let's think about, since we're finding the true difference of average lap time and we're doing old minus new, if the new tires really give you a faster time, are we going to have a positive answer or a negative answer or what?
Negative.
Okay, so Tim says positive, Alice says
No,
negative. Why are you just switching because Alice said negative?
No.
Wouldn't it be
because,
positive,
It'd be
but
positive because the old times
because it's
marker.
less time, but really
Yeah.
it's a better score even though it's negative.
Yeah, so the difference, old minus new, old is slower minus new, so it's going to be a positive number, but that means that the new tires give us a faster time.
Oh, because the old one is bigger.
Yeah.
Oh.
Okay?
Yeah.
So when we do mu1 minus
Wow.
mu2, should be a positive number. Positive number means faster new tires. Faster
Wait,
new tires. You don't actually have to like say that mu1, we're not doing a significance test, so we're not saying like mu1 minus mu2 is greater than 0. We just need to write it down, at least I do, to keep it straight in my head.
Well, I'm writing one.
You just took up like half the space. We're just on state.
Okay, we'll go through plan in our head. Plan, what are the 3 conditions? Random, normal, independent. So random, how do we know it's random?
It's just a rest twice.
Says it, right? Plan,
Oh, we're doing it in our head.
we are. Random, check off. It says SRS and SRS. Normal, how do we know that?
CLT.
Yes. So for normal, because we're looking at means, it's either going to say the population distribution is normal, or you check the CLT. And the CLT checks off because we have 38 and 40 for our sample size. So normal, CLT, check. And then independent would be that our sample size is less than 1/10 of our population, and we are going to assume that this person has been racing for a long, long time. Okay? So independent, check. Now we get to do. So I have my state, my plan. Now we're going to do. So we're going to use a 2 sample T interval. 2 sample T interval. But we also need to write down our like general formula, especially those of you taking the AP exam. What is the general formula for a
Um,
confidence interval?
estimate plus or minus margin of error.
Estimate plus or minus the margin of error. So, you're gonna go to stat, go over to tests.
Do we have to write like mu1 minus mu2 plus or minus z star 95 and the standard deviation after that, or does that suffice?
That's good enough. Two sample t interval, 0 on my calculator. And if you have the data as a list, you would use data, but we just have the statistics. So X bar 1 was 96. Standard deviation for the first sample was 3.5. And the sample size for the old tires was 38. And then X bar 2, 94. Standard deviation for our second sample, 2.5. And 40 laps there. And what confidence level?
What's pooled?
You don't need to worry about pooled.
Is it pooled? Is this question pooled?
No.
What, okay. Will you
We
tell
don't
us-
do pooled.
Will you tell us if it is pooled?
Yes, I
Is
would.
pooled
But I
on-
just said we don't do pooled.
Is pooled on the AP test?
No.
Then what is it for?
I'm not a good student.
It's for more advanced statistics,
I'm not a-
calculus-based
I'm not a very
statistics.
good swimmer though.
Okay, good. That's why we're not going to use the pool. All right. So we have our confidence interval from 0.61 to 3.381. Sorry, my decimal disappeared.
And our degrees of freedom are 66.69.
Yeah, it's not, so when you have two samples, it's not just like one minus your sample size, because there are two sample sizes, so it's this really weird formula. You never have to know how to do it. But if you want to find your degrees of freedom, just do your interval and it gives it to you. But there's not going to be questions about it because it's not a fun formula.
The rest of them fun?
It'll only give
Heck
you-
yes.
Uh,
Any questions on the confidence interval? All right, and then we're going to conclude.
yes.
Use black. So, how do we write a confidence interval conclusion?
We are 95% confident that the interval from
We
captures the true difference.
are 95% confident that the interval from 0.619 to 3.381 seconds captures the true difference of average. How are you done before me? Lap times. Average lap times between new and old tires. I even abbreviated. You must write really fast.
Yes. I even had time to go back and rewrite the mistake.
No.
So, is this?
No. We have to do
No, we're not going to do a significance test yet. But remember,
Yeah.
we talked about